welcome in channel of Mr. Statistician. Today we are solve GATE 2021 question number 38 of statistics paper. Let's get start. Let x of order 1 less than x of order 2 less than x of order 3 less than x of order 4 less than x of order 5 be the order statistic corresponding to random sample of size 5 from a uniform distribution 0, theta, where theta belongs to 0, infinity. Then which of the following statement is correct? P. 3x of order 2 is an unbiased estimator of theta, and Q. The variance of expectation of 2x of order 3 given x of order 5 is less than equal to variance of 2x of 3. We first check P statement is correct or not. We know that if x1, x2, xn be a random sample from uniform 0, theta, then x of order r upon theta follows beta distribution of first kind with parameter r, n minus r plus 1. This is the most important result. You always remember this result. Here, sample size n equal to 5 and r equal to 2. Therefore, x of order 2 upon theta follows beta distribution of first kind with parameter r is 2, n is 5 minus r 2 plus 1, that is equal to beta distribution of first kind 2, 4. Therefore, also we remember, we know that if x follows beta distribution of first kind with parameter m, n, then expectation of x equal to m upon m plus n. This is the expectation of beta distribution of first kind. So here x of order 2 upon theta follows beta distribution of first kind. So their expectation is equal to, here m is equal to 2 and n equal to 4. So 2 upon 2 plus 4 is equal to 2 by 6 equal to 1 by 3. Therefore, expectation of x of order 2 upon theta equal to 1 by 3. We multiply both sides. We multiply both sides by 3 theta. We get 3 theta into expectation of x of order 2 upon theta is equal to 3 theta into 1 by 3. We know that expectation of c times x is equal to expectation of cx. C is a constant. By using this result, 3 theta into expectation of expectation of second order statistic upon theta equal to expectation of 3 theta into second order statistic upon theta is equal to theta. Therefore, expectation of 3 into x of order 2 is equal to theta. This implies that for all theta belongs to parameter space H. This implies that here parameter space is script H is equal to theta such that theta belongs to 0 to infinity. This implies that 3 into x of order 2 is an unbiased estimator of theta. So statement P is true. We check second statement is true or not. We solve this statement. This statement also we know the sum theorem. This second statement is the application of Robb-Blackwell theorem. So we write statement of Robb-Blackwell theorem. Let u is equal to u of x1, x2, dash dash xn be unbiased estimator of parameter psi theta, gamma theta, and let t is equal to t of x1, x2, dash 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 xn be sufficient statistics for gamma theta. Consider a function phi of t of the sufficient statistic defined as psi of t is equal to expectation of u given t is equal to small t, which is independent of theta, because t is a sufficient statistic for theta, then expectation of phi of t is equal to gamma theta and variance of phi of t is less than equal to variance of u. This statement is used to solve this theorem. Here, random sample from uniform 0, theta. In this problem, u equal to 3 into x of order 2, t equal to x of order 5, phi of theta is equal to theta, phi of t is equal to expectation of u given capital T equal to small t is equal to expectation of 3 into x of order 2 given x of order 5. This is given in second statement. Similar to phi of t, we prove in statement P is 3x of order 2, that is u is unbiased for psi of theta is equal to theta. So first condition is satisfied. Here u be the unbiased estimator of parameter psi theta, and second condition is t is be the sufficient statistic for psi theta. We prove that t is sufficient for psi theta. Here t is equal to x of order 5 is sufficient for phi theta. We prove this. First we prove that t equal to x of 5 is MLE of psi theta, that is theta. So here given that x1, x2, xn is random sample from uniform 0, theta, therefore likelihood function L of theta given x vector equal to product of I equal to 1 to 5, because here random sample is of size 5 equal to product of I equal to 1 to 5, 1 upon theta is the density of uniform 0, theta. is equal to 1 upon theta raised to 5 is equal to 1 upon theta raised to 5. Therefore, delta L by delta theta is equal to minus 5 upon theta raised to 4 is less than 0 for all theta belongs to parameter space, which implies that likelihood function L of theta given x vector is decreasing function of theta. So decreasing function of theta, therefore L is maximum if theta is minimum subject to constraint 0 less than x of order 1 is less than x of order 2 is less than x of order 3 is less than x of order 4 is less than x of order 5 is less than theta. Here, which implies that minimum value of theta is x of order 5 equal to theta, which implies that MLE of theta hat is equal to x of order 5. This implies that t is a MLE of theta. So we prove that t is a MLE of theta. We also prove that we need to prove that t is sufficient for theta, that is phi theta. T is sufficient for phi theta. We know that important property of MLE. If t is MLE of theta, then t is a function of sufficient statistic for theta. Here MLE t is equal to x of order 5 is function of x of order 5. This implies that t equal to x of order 5 is sufficient for theta. So Raw-Blackwellization theorem's two conditions are satisfied. First is U is unbiased estimator for theta and T is sufficient statistic for gamma theta. So phi of t is equal to expectation of U given T by above theorem. Therefore, by above theorem, expectation of y of t is equal to gamma theta. We do not need this. We need second part. Is variance of phi of t is less than equal to variance of u. Here variance of phi of t is equal to expectation of u given capital T is equal to small t is less than equal to variance of u. Variance of u, here u is 3 into second order statistic. Here we see that variance of expectation of 3x2 given x5, that is, this is equal to expectation of 3x2 given x5. We assume that this value to solve this question, that is, this is less than equal to 3x2 is less than equal to variance of 2x3. Sorry, here 2x3 here 3 of x2 is correct. In this question is correction is 3x2. So statement Q is also true. So in this MCQ, both statement P and Q are true. Thank you. Please like, share and subscribe.